Hello, my name is Shahrul Hafiz and today I'd like to go through the Euler method. So we have my explanation for the Euler method, which is a first order numerical procedure for solving ordinary differential equations with a given initial value. And so to derive the Euler formula, we are going to use the gradient of the curve, which is xn minus 1, yn minus 1, and the step size, which is depending on the x-axis, h, to find this unknown height here, the value between y0 and y1. The gradient usually is rise over run. So knowing that means function of x0 and y0 equals to z, which is the unknown height, over h, which is the step size, which is also our run, so to say. To derive our Euler formula, we are going to bring h over to the left side, which makes it z equals to y0 plus h times function bracket x0 comma y0. Therefore, deriving Euler's formula, yn equals to yn minus 1 plus h times function bracket xn minus 1 yn minus 1. So, as an example, I'm going to do this question here, and they're asking for us to find an approximate value of y1. So here we have here the Euler method and the step sizes that I'm going to use. My n value will be this, x value, y value, and same for this side, and x, y values. So for the n values over here, for both columns, I have used the similar formula of just adding 1 to their respective value. And when I drag on, it will show until I got a 10. And for x value, both x value columns, I use this respective formula of for example, C14 plus C$11. The dollar sign, as for our purpose, is to make sure the 0.1 and the 0.01 is consistently being added here without any additional errors. And it will be shown until I get a x equals to 1, which is what the question is asking for. And this is my y value using this formula, which is using the formula of my previous y value plus the step size, and using basically just this formula right here to get this, and drag it along until if it's x equals to y. Same for this side, except this one has around like 100 rows to reach x equals to 1. So now this is my working for the question of solving it using the old-fashioned first order ODE. First, just the usual cross multiply, then choose integration half x plus c 1/3 y cubed. Then when you get x equals 0, y equals to 1, sub in x and y values, so you get a half 0 square plus c 1/3 and 1 cubed. You so ultimately get a c equals to 1/3. For this value, you must submit into c of the equation, which becomes 1/3 y cubed equals to half x squared plus 1/3. Then when x equals to 1, which is what it's asking for, 1/3 y cubed equals to 5/6. Then y cubed into 5/2, which becomes to 2.5. Then to get rid of the cube, I made it power to 1/3, and I get the answer of 1.3572. So using the ODE answer I got from that working, I apply it to both of my y values over here. As you can see, my error margin for this step size set over here will be 0.0179, which may look small, but compared to the other one, if I take the ODE minus this value, getting a 0.0018. This concludes and shows me that the smaller the step size, the smaller the error margin is between the shown curve and the actual answer curve. That's it for my video, bye bye.